Hello everyone, I'm Qingwen. Today I will talk about our paper published at Robotics and Automation Lecture, DUFOMap, Efficient Dynamic Awareness Mapping. Currently, most of SLAM methods use data from multiple sensors to get the pose and integrate point cloud frame into a global map, as shown here. However, you might notice the yellow points on the map. Those are dynamic points. These points are from moving objects captured when we are building the map. In localization tasks, dynamic points can reduce accuracy by introducing confusing feature or misleading the matching process. For global path planning, dynamic point can lead to poor decision. If the system mistakes these points as part of static environment, it may classify them as obstacles, making the areas untraversable. This could result in longer, inefficient, or even failures in path planning. So we want to detect dynamic points and remove them in the map. The motivation behind DUFOMap is simple. What kind of method we want? We want a method that with no assumption on sensor types, just point cloud is enough to run, like all sensor types present here. We want the method that works across various scenarios, from highly dynamic environments like train station to complex two-floor structure where the height-based method fail, and of course in small scale and large scale like driving scenarios. Existing methods often need to tune lots of parameters because of changing sensor scenario. For example, they have high threshold set, ground synchronization parameter, or tuning configuration for different sensor types. Our goal with DUFOMap was to create a method that requires little to no parameter tuning, maybe just one or two. Finally, real-time operation is crucial for application in real robots. DUFOMap has been maximum optimized engineered, making it the fastest method for detecting dynamic points and providing a clean map in the real time. So, method. Actually, points are not only points, but also indicate more information for 3D space by using recasting. For our method, recasting is performed for each point from the sensor position. We propose to look at the direct neighbor of a voxel and the surrounding voxel to decide free space. Then the key insight is that if a region has been observed as empty at one time, like red space here, point observed inside this region at another time has to be dynamic. Of course, that's not the only thing we did in DUFOMap, but we also involved two strategies to consider real sensor noise and localization error, all of them for the same goal, build a free map. Due to the time limit, I cannot dive into, but feel free to check our paper and code later. So to summarize our DUFOMap method, here are steps. We accumulate point clouds like normal map we do, but we will use them to build a free space map through recasting. And then if any point fall into this free region, as shown in the red space here, they are dynamic. That's it. Simple, but effectiveness. Now experiment. Keep that in mind. For our DUFOMap, we always have same parameters to show our robustness and generalization on different sensor types and scenarios. Here are quantity results for DUFOMap on 64, 32, and 60 channels LiDAR from autonomous driving to indoor robotics scenarios. And here the runtime of DUFOMap with only around 50 milliseconds per frames. Now you may be interested in more qualitative results. Here are the comparison before and after DUFOMap cleaned in the highly dynamic train station data. And this one is collected by Levox Mid 360 sensor equipped with quadruped robot to move from first floor to the second floor. And here is the clean map demo from the full Kitty sequence. We want to showcase our method can run on a really big full town maps, etc. On the left is the yellow point are ground truth dynamic, and right is the DUFOMap results clean map. And here it's totally different sensors with RGB depth camera to get the point cloud, and I'm moving a cup in the table, and then it's a DUFOMap can also remove all the dynamic here. And here is the KTH campus. So we collect this by Leica 360 sensors, which is not typical sensor in the robotic script, but it's quite a common sensor in the SLAM scenario where they did for the ground truth map. And here we collect during the off-class time, and everyone want to go to the lounge. So you can see a lot of dynamic here, but we can remove them automatically using DUFOMap. So our method, DUFOMap, supports many sensor types, different scenarios, no parameter tuning, real-time operation. Thanks for the watching. Want to know more details? Check our paper, project page, and source code. We also provide the benchmark code for all methods we compare with in the paper. Last but not least, we have DUFOMap in Python now. Pipe install DUFOMap and run it in your data. You can get your clean data within 1 minute based on how many frames you have. And this is involved by Cflow, which we publish in ECV. And this is not, that's why it's not only binary classification, but you can get more information from the points, like the flow or velocity of each point. And thank you. Check our KTH RPL GitHub page and to know more about our work.